haven't learned before, we are going to find out if two vectors have the same direction, which is not the same as orientation, as you might know by now. And when two vectors can, when one vector can be expressed as a linear combination of two different vectors. This is new, this part and this part. It's the new thing we are learning. But as we started before Easter and then continued, I want to I want to just revise a bit what we've learned. So you have everything here all together. So first thing, points. Points are expressed like coordinates, and you know perfectly by now how you express how do you have to represent those points in the axis. It's like if I have point A, which is 1, 2, it is I move one position to the right because that's the x-axis, the y-axis, and 1 is positive, so I move to the right, and I move 2 up because it's 2 positive, so this might be point A. If I want to draw minus 3, 1, it is the same, but now it's a minus 3, so it means that in the x-axis, I'm not going to the right, I'm going to the left, 3 positions, so 1, 2, 3, and I'm moving 1 up because it's a positive for the y, so that's point B. And now if I want to move to draw point C, that would be 0, minus 4, so I'm not moving in x-axis, and I'm moving 4 positions down because it's a minus 4. So that's point C. Okay, now, if I would like to calculate vector AB and vector AC, sorry, BC, what do I have to do? Well, I just put together A at the beginning, B at the end, and B at the beginning, C at the end. So those are the vectors BC that goes from B ending in C and goes from A ending in B. That is, I mean, we can calculate it just as we've learned, like, okay, if I want to calculate AB, what I have to do is take the components from B and subtract all those components from A. In this case, it would be x with x, y with y, minus 3, minus 1, that is minus 4, and 1 minus 2, that would be minus 1. Okay, if I want to calculate the same thing with BC, what I might do is the same, but with B and C. So 0 minus minus 3, that is 3, and minus 4 minus 1, that is minus 5. Okay, that can be done calculating, but I can do it with a picture as well, because this vector will represent the moves I'm making to go from A to B. So that is, if I'm in A and I want to move to B, what do I have to do? I have to move 4 positions to the right, have to move this way and this way. So how many moves I've made? I've made 1 position here, 2, 3, and 4, but to the left, so that's a minus 4, and I've moved 1 down, so that's a minus 1. So it doesn't matter if I do it with a picture, if I do it calculating, it will be the same result. Now I'm doing the same thing with BC. Here, if I just see the picture here, it is like, okay, to go from B to C, what do I have to do? I have to move 3 positions here, so 1, 2, 3, okay, that's that 3 here, and 5 positions down, 1, 2, 3, 4, 5. So to go from B to C, I have to do that. 3 to the right, 5 down. So it is the same thing. It doesn't matter how we calculate it, it would be the same. Sometimes we don't have the picture, or sometimes we have bigger numbers, so it's easier to just calculate it as I've told you. Okay, one vector is unique in the way that it has one own length, one direction, and one orientation. What's the difference between direction and orientation? Okay, for example, AB and BA have the same direction, but they don't have the same orientation, okay? So these two vectors, well, they're not equal, they're different, but they have exactly the same direction because they are like on the same line. So it doesn't matter if I go from A to B or if I go from B to A, that has the same length on the same line. So this means that they have the same direction. Orientation will be, and this is something different, this wouldn't be the same thing. If I'm moving from A to B or from B to A, that's important, okay? That's the orientation of the vector. Okay, remember what we could do with vectors? All the operations we can make, it's addition. We can add two vectors. And remember, we can add the vectors, like here, for example, if I want to add AB to BC, if I draw it like I start in A, I continue with B. If I write the following vector starting in B and finishing in another point, this is just the result of the addition. Not sure if you remember this, but well, you have it in your book, perfectly explained. So that would be AC. I can do that, or I can just like add them, let's say it in a way. So if I want to go from A to C, this would be like, okay, I add this here and I add this here. So I get a -1, -6. It makes sense because it's if I move from A to C, I have to move 1 to the left and 6 down. So it's the same thing as if I add them. Okay, we cannot subtract, well, we can, but we can't just easily subtract vectors. What we do is, okay, if I want to subtract them like here, no problem. I just, instead of writing a plus sign, I write a minus sign here, and I do the same thing, but now subtracting -4, -3, that would be -7 if I want to subtract it, -1, -4, -5, that would be 4, and that's it. Okay, but to subtract, remember what we do is if I have one vector here, u, and one vector here, which is v, and I want to subtract u minus v, I don't do this. What I do is I add the negative vector. So first, I change the orientation of this, like drawing it to the other side, and now I can add these two vectors, and not this one, because now it's like subtracting it. This would be minus v. Okay, that's just to remember because we learned this in class. Multiplication. Can we multiply all the vectors? Well, not okay. What I can do with the vectors is to multiply by a number. I mean, I can write 3 times AB. That would be like, okay, I have AB, which was here. If you remember, it was like a -4, like here, and 1. So imagine we have this vector here, which is AB. So 3 times this vector would be, okay, I repeat it and then I repeat it again, okay? So that would be 3 times AB. Okay, now I can do it with a picture, but I can just do it multiplying the components. So that would be 3 times -4, it is -12, 3 times -1, it's -4. So what I get is this, like this point, which is like a vector. I mean, the point I get to can be called like the vector 0, C, or just coordinates are the same as with the point C. So that's a way, and that's why I told you that sometimes points can be represented by vectors, and the same thing happens on the other way. It's like, okay, I finish here. That's my ending point. Okay, I can multiply vectors, but that is something you will learn in the future, not this year. You can multiply vectors, but you have different kinds of multiplications and you get different things. So that's something you will learn in the future. What you can never do is to divide vectors. That's something that can't be done. I mean, you can multiply, not this year, you won't learn it, but it can be done, but division can't be done, okay? Okay, now, what is new here is how do we find out if two vectors have the same orientation or not? I mean, same direction or not? Well, same orientation can also be calculated, but what's interesting, not here in this exact point of the unit, but later when we learn about how to calculate all the equations of lines, we will need to know if one vector has the same direction as another. And how do we find that out? Well, sometimes it's easy because if, for example, I see one vector, let's call it u, which is 1, 2, and I have another vector which is like 3, 6, for example. Well, I can see that this 1, 2, 1, 2 would be like a vector like goes here, and 3, 6 would be a vector that comes here. So it's just a bit longer, and that's it. And that's true, that's the same direction. Even if I had this other vector, which is -1, -4, this would be okay, the same, -1 here, -2 down. So it's the same. I mean, it's on the same line, so all the three of them have the same direction. Well, U and W have different orientation as well, but they have the same direction. And what's important for me is if they have the same direction or not. Not, I don't care about orientation, okay? So here it's clear what we have to do, but it's not as clear. It's not always as clear as this. So to do it, we have one kind of trick to find it out, which is like this. I mean, if I want to know if two vectors have the same direction, and let's say, for example, this is one vector, and the other one is like this, what I have to do is to compare the two components, x with x, y with y, like this. I do this division. 1 divided by -2, okay? I do this. And if this equals, in case this is equal to 4 minus 6, then if this is true, I mean, that's the question I have to make. And if this is true, if the answer is yes, I can assure that these two vectors have the same direction. What happens here? Here I would get -1/2. And here, if I calculate this and I simplify it a bit, it's impossible to get 1/2 here. I would get 2/3 negative as well, but 2/3 anyway. So do they have the same direction? And the answer is no, they don't. If I draw it, I can see it clearly that here I have like 1, 1, 2, 3, 4. Okay, so this is U. V is -2, 1, 2, -6, 1, 2, 3, 4, 5, 6. So this comes here. I mean, not because my picture is not very good, but because they are not on the same line. I mean, this line would continue like this line would continue like that. So they're not the same line. So my answer would be no, they don't have the same direction. And you only have to do that. You only have to check if when you divide them, you get the same thing. Be careful with the signs of it, because it can happen that imagine instead of having this -6 here, I had like a 4, let's say that, okay? And I have to do the same thing. I have to calculate that. So that would be, okay, I do the same. I write 1 divided by -2. Is it the same as 4 divided by 4? Well, just the sign is not the same, so it's impossible. But so that would be a no. But if instead of having here 1/8, 1/4, I had an 8, okay, this would be -1/2, and this would be 1/2. Is this the same? The answer is no. So they don't have the same direction. And again, if you draw it, just, I mean, it's easier in your notebook with a checkered paper, but if you do it here, it's like, okay, 1/4 is something like here, -2/8, it is something like here. It's impossible for them to have the same direction, okay? Sometimes it's crystal clear that they don't. But when it's not that clear, you just do this and you find it out. And that yields to the next thing that we need to learn, which is a linear combination. Well, a linear combination is a way of expressing one vector using a linear combination of the others. What does it mean? What's a linear combination? If it's linear and you combine them, what you can do with two vectors is like you have u, which is one vector, let's make it easy, 1, 2, and you have v, which is another vector, which is, let's make it easy again, 0, 3. Okay, you have these two vectors. Okay, I can express any vector I want if these two vectors are not with the same, don't have the same direction. I can write any other vector as a linear combination of this. Which means, for example, this is u. 1, 1, 2. Okay, this comes here. Okay, and v, which is 0, 3 in this case. So this is 0 in the x-axis, 1, 2, 3. This is v. Okay, what does it mean, a linear combination? Linear combination is that I take this vector u and I multiply by any number I want, let's say a, and I take this vector v and I multiply it by any number, and I can add them or subtract them, and I can get any vector I want. For example, imagine I want to draw this other vector, and I want to express it as a linear combination of u plus v. What should I do? I mean, can I get this using that? Look, remember how we added vectors? Instead of writing v, let's write minus v to get this one, okay? If now I need to know to write like a parallelogram here to find the beginning and the end, maybe if I do this like a bit shorter, I mean, instead of taking v, I take 1/2 of v. And if instead of having one u, I have like 3 times u or something like that, maybe playing with that, I can get this. Okay? Imagine, for example, the opposite way is easier to understand, which is like, for example, let's say this is 2v, okay? And now let's write minus u here. If I add them here, I would get that vector, okay? So this vector can be expressed as minus u plus 2v. And that can be done with any vector you want. For example, with this, instead of having that, we should have different options, but in the end, it will be the same. Maybe instead of having minus v, I have to write minus u. You don't know. I mean, you don't know with the picture sometimes. Sometimes it's the same thing. You can see it clearly what you have to do. Okay, in this case, imagine I have these two vectors, 1, 2, and 0, 3. And let's say this number here, more or less with a picture, it is 10, 6. Okay, can I express this vector here as a linear combination of u and v? How can I do it? Okay, what I want to do is like, okay, let's plan a system of equations, because if I can express it, first thing I have to do is to check if they have the same direction or not, because if they have the same direction, I can't express any of the vectors on the plane like one linear combination of the others. But if it's not, I could. So I see clearly that not, because that's impossible to be like this. So it's impossible. So they are not on the same line. They don't have the same direction. So I can express this other vector, let's call it W, as a linear combination of those. To do that, what I have to do is, okay, I plan this. W would be A, I don't know what A is a number multiplied by 1, 2, plus B, which is any other number that I don't know, multiplied by vector V. I need to get this W, which was 10, 6. Okay, if I do that, what do I have to do now? I take X component with X component and Y component with Y component, and I can plan the system like this. 10, which is the first X here, is A multiplied by 1, so A, plus B multiplied by 0. So B by 0, that would be a 0. And this other vector is 6 has to be equal to 2A plus 3B. Okay, here it's easy because I don't have like a system of equations, because A comes just straight away. A has to be 10. If A is 10, then 6 has to be 20 plus 3B. So if I move this 20 here, I get minus 14. It is 3B. So B equals minus 14 divided by 3, which is minus 5 point something. What does this mean? Okay, I need to multiply. A is 10. So it means that vector u needs to be multiplied by 10 So if I write u, this vector u, 10 times like this, like in this line, write 10 times u, and then you draw, sorry, not write, you draw minus 14 thirds b, this b minus 4, well, it's like 5, well, now minus 5 something. If I do that down here, if I add them, I will get that vector. That's the meaning of that. Okay, so vectors with the same direction, we just compare the components, and linear combination, what we have to do is to find the numbers that will make that combination possible. Okay, now what I want you to do is to do this exercise on page 162, exercise 2 and 3, that are related to this. Really, I mean, I can multiply vectors, but in this school year,